Okay, we have a round steel ball rolling around the inside of a frictionless spherical ball. Actually, I should have said it was sliding around, because rolling, all kinds of weird stuff happens when you're rolling that we have not learned to deal with, nor, for the most part, will we learn to deal with. But, so we're just going to say it's frictionless and sliding, and it's good enough, okay? So, let's use a nice shade of forest green here. And this thing is moving around with an angular velocity of omega. It's going shoom, 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 angular velocity omega. And we want to find the angle theta that rises up the side of the bowl. So to start with, let's do our circular motion kinematics. And this thing is going around. It's going, come on. There we go. It's going around like, that's not a circle. Okay. I know. I'll draw a circle. Ha ha ha. Perfect circle. Okay, so it's going around, going clockwise. At least we've shown it that way there. Okay, it is accelerating at any given point in time. It is accelerating towards the center. Okay, this circle has a radius of r. So, and we know it's going around with angular velocity omega. So a equals omega squared r. Why did I use little r here instead of big R? Well, I'll tell you why. Because big R is the radius of the sphere. So that's, if you look at this top circle here, this solid circle, which is the top of the bowl, that's the big R radius. But the radius of the circle is little r. That's what I'm using for little r. And so if you look at the trig, this dotted line I've just drawn here, for example, would be little r. And the hypotenuse of this triangle would be big R. So little r is going to equal big R times the sine of theta. So we're going to get here, a equals omega squared big R sine theta. Okay? All right, so let's, without further ado, let's do a free body diagram of this ball. And let's say, oh, I'm going to do it when it's over here. Okay, so the ball is right there. And so let's get to work on this. Now, first of all, this angle theta is here. What that means actually is that that's going to be the angle that, oh man, hang on. Okay, let me think. That's going to be the angle the slope, the surface the ball is on makes with horizontal, right? So let's think this through. Here's our ball, okay? And we want to know what's, I think this angle here, we want to know, is that theta? Well, think about the extreme cases. When theta equals 0, it'll be a flat surface, and then this angle will be 0, right? Okay. When theta equals 90 degrees, then it'll be going around the outside edge, you know, practically hugging a vertical wall, and then theta would be about 90 degrees. So, okay, that makes sense. So this angle is theta, okay? Now, here's our block, okay, or it's not a block, it's a ball, okay? And again, just assume sliding because rolling does all kinds of nasty things. And it probably would slide more than roll, okay? So now we've got forces acting on it, which are mg and a normal force on the wall. Since it's sliding in a frictionless bowl, there is no friction. Therefore, of course, this normal makes an angle of theta with vertical. Is that correct? Let's make sure. Yes, it is. Okay. So now let's do an FBD for the ball. Okay, an FBD for the ball. We've got the forces I just drew, which are normal. Actually, I made that a little steeper. Okay, I'm so picky. All right, there's theta, and there's our mg. Which direction should our axes go? Well, which direction is the ball accelerating? It is accelerating towards the center of the circle, right? So, like that. So, therefore, our axes must go somehow like this. So, I'm going to do that, x, y. I could have pointed it inwards, the x, but whatever. Okay, so, going up and cos theta, and going left and sine theta, going down mg. Okay, so it looks like we do sum of forces equals mass of the ball times A. Okay, in the x direction, we've got negative n sine theta equals m times a in the x direction, which is going to equal, right, so this, our acceleration, our centripetal acceleration to the left will be, that's our negative omega squared r sine theta. So that's going to be negative m omega squared r sine theta. Okay, hold on. Okay, let me do my theta a little less ugly. Okay, and then in the y direction, we are going to have n cos theta, okay, minus mg equals may, which we hope will equal 0. Okay, so let's see. This is going to amount to, so let's solve the y equation first, and let's switch to this sort of cobalt blue type color. Okay, cobalt blue, yeah. All right, so this is going to give us n equals mg over cosine theta, right? Yes, okay. And then we can plug that in up here for this, okay? And so what that gives us, we bring this guy down to, is mg, well, negative mg sine theta over cosine theta, okay, equals negative m omega squared r sine theta. Okay, so now, okay, right, so this is our equation here. First of all, let's see, we can cancel, I'll switch to, how about orange, just to make this as disgusting as possible. We can cancel sine theta, we can cancel the m, cancel the negative signs. So what we're going to get now is g over cosine theta equals omega squared r. And that gives us omega squared equals g over r cos theta. So omega, the omega we'll get is square root of g over, oh wait, hold on. Oh, I had to find theta. Whoops, okay. So, well, it happens. Okay, so let's take this and go the other way and find g over omega squared r equals cos theta. So that's just bringing the cos theta over and having it switch places with omega squared r, which means theta is going to equal the arc cosine of g over omega squared r. Okay, so now to answer the questions we had, I mean, we had to find that, right? And then we want to ask questions, is there a maximum possible omega and a minimum possible omega? And so the ways to look at this, or the way to look at this, is to say, well, okay, what are the maximum possible values for cosine, right? So this can be 1, cosine can be 1, or the cosine can be 0, okay? So at g over omega squared r equals 1, that's one extreme, okay? That's the maximum value for the cosine of theta. And what that means then, we need to find what this would mean for omega. This would mean omega squared equals g over r, or omega equals g over r, okay? So that's one case. Okay, is it the maximum or the minimum? Not sure yet, and we will find out in just a moment. Let's see, I don't want to bring the next question in, but okay. So this is one of our extreme cases. The other case is where theta, where cosine theta equals 0. So cosine theta equals 0, which means then g over omega squared r equals 0. And in that case, well, actually that's going to get weird, because then you're going to get omega could potentially, really for this case, omega has to go to infinity, right? So the cosine theta equals 0 case is the case where theta must equal 90 degrees, which means that's the case where you're riding the lip of the bowl. So as you're riding the lip of the bowl, which means you are at the maximum possible, I have no idea what that zappy sound was. That's a little scary. As you're riding the lip of the bowl, you can go infinitely fast. Okay, so this ball can zip around as fast as you can get it going, and it won't, at least in theory, it won't fly out of the bowl, assuming you're keeping the bowl perfectly level and there's nothing else going on here. This case, on the other hand, is when cosine of theta equals 1, and this is when you're sitting at the bottom of the bowl. So, bottom of bowl. So it looks as though to even be moving at all, you need to have some minimum omega, which is going to be, square root of g over r. Jeez, this is horrible. Okay. Bottom of bowl is when omega is the square root of g over r. So if you had a 1 meter, what this seems to be saying is if you had like a 1 meter diameter bowl, actually the ones I've got in the lab they're Van de Graaff generator covers and like 12.5 centimeters in diameter. So for a diameter of, they're 25 centimeters in diameter. So the radius is 12.5 centimeters. So let me just hold on and let me go out here and take this. So this should be our minimum omega. Okay. And I just want to find this out. So let's see. It looks like, where are we now? Minimum omega is going to be square root of 4. Let's see, 4. Come on, what is this with this piece of crap? Okay, for r equals 0.125 meters. Okay.